They told him a coffee can and some wire wouldn't detect submarines. Then his makeshift hydrophone picked up a U-boat at maximum range and saved an entire convoy. This is the story of how one stubborn sonar operator broke the rules and changed naval warfare with trash. The Atlantic Ocean in 1943 was a graveyard. German U-boats were sinking Allied ships faster than they could be built. Thousands of sailors were dying in the freezing water, and the technology meant to detect these submarines wasn't working. Standard hydrophones were failing. Detection ranges were terrible. And one operator decided that if the Navy wouldn't fix the problem, he'd fix it himself, with a coffee can. His name was Chief Petty Officer James Hutchins, and this is the story nobody talks about. Let's set the scene. It's March 1943. The Battle of the Atlantic is at its worst point. German Admiral Karl Donitz has unleashed his wolf packs, groups of U-boats hunting together, coordinating attacks, overwhelming convoy defenses. They're sinking over 100 ships a month, merchant vessels, troop transports, cargo ships full of food, fuel, ammunition, everything the Allies need to keep fighting. And the Allied navies are struggling to fight back. They have destroyers, they have corvettes, they have depth charges, but none of that matters if you can't find the U-boats in the first place. That's where hydrophones come in, or at least that's where they're supposed to come in. A hydrophone is basically an underwater microphone. You drop it in the water and it picks up sounds, engine noises, propeller vibrations, the creaking of a submarine hull under pressure. If you can hear a U-boat, you can find it, and if you can find it, you can kill it. But here's the problem. The hydrophones in 1943 were garbage, absolute garbage. They were based on designs from World War I, heavy, clunky things that barely worked. The detection range was maybe 1,000 yards on a good day. In rough seas, forget it. You'd be lucky to hear anything at all. The sound quality was muddy. Everything sounded like static. A U-boat engine could be rumbling a few hundred yards away, and you'd miss it because it sounded like every other piece of noise in the ocean. Waves, fish, your own ship's engine, all of it just blended together into useless noise. Sonar operators hated them. They'd sit there for hours, headphones on, listening to nothing, straining to hear something, anything, that might be a submarine. And most of the time, they'd hear nothing until the torpedoes were already in the water. Chief Petty Officer James Hutchins was one of those operators. He served on the USS Bogue, an escort carrier tasked with protecting convoys crossing the Atlantic. His job was to listen, to detect U-boats before they could strike, to give his ship enough warning to launch planes or call in destroyers. But the equipment kept failing him. Day after day, convoy after convoy, he'd sit at his station with those terrible hydrophones and he'd hear nothing. And then ships would get torpedoed, men would die, and he'd know that if his equipment had been better, he could have stopped it. So Hutchins started tinkering. He wasn't an engineer. He wasn't a scientist. He was just a guy who refused to accept that this was as good as it could get. He started taking apart the hydrophones during his off hours, studying how they worked, trying to figure out why they were so bad. The main problem was sensitivity. The hydrophones weren't picking up faint sounds. They needed the sound to be loud and close before they'd register anything. And by the time a U-boat was loud and close, it was too late. Hutchins figured that if he could make the hydrophone more sensitive, he could hear U-boats from farther away. But how? The Navy's equipment was what it was. He didn't have access to better materials. He didn't have a lab. He had a workshop on a ship in the middle of the ocean and whatever junk he could scrounge up. Then one day he was drinking coffee, and he looked at the empty can, and he had an idea. Coffee cans back then were made of tin. Thin, light, and most importantly, they resonated. If you tapped one, it would ring like a bell. Hutchins wondered if that resonance could be used to amplify faint sounds underwater. So he grabbed a coffee can from the galley, cut it open, fitted it around the hydrophone sensor, used wire and waterproof tape to seal it, and he created what basically amounted to an acoustic amplifier. The can would catch sound waves and funnel them into the sensor, making faint noises louder. It was crude, it looked ridiculous, but Hutchins didn't care. He tested it in a bucket of water first, tapping on the side and listening through headphones. The sound was clearer, sharper. He could hear the taps from farther away than with the standard hydrophone. He knew he was onto something. But when he showed it to his commanding officer, the response was immediate. No, absolutely not. Navy equipment is Navy equipment. You don't modify it. You don't stick coffee cans on it. You use what you're issued and you don't complain. Hutchins tried to explain, tried to show the test results, but the officer wasn't interested. Unauthorized modifications could get you court-martialed. It could get you kicked off the ship. And besides, if the Navy's engineers wanted better hydrophones, they'd design better hydrophones. Who was Hutchins to think he knew better? So Hutchins did what any good sailor would do. He ignored the order. He waited until his next shift, swapped out the standard hydrophone for his modified one, and he started listening. The difference was immediate. He could hear things he'd never heard before. The distant hum of a merchant ship's engine miles away, the clicking of shrimp, the low rumble of a whale. The ocean wasn't silent anymore. It was alive with sound. And then one night in April 1943 he heard something else. A faint, rhythmic thrumming, slow and steady. Not a merchant ship, not a whale. It was too mechanical, too deliberate. It was a diesel engine, a U-boat. Hutchins checked the bearing, checked the distance. The signal was faint, but it was there. He estimated the U-boat was at least 4,000 yards away, maybe more. That was well beyond the range of the standard hydrophones. His coffee can mod was picking up a signal that should have been impossible to detect. He reported it to the bridge. The officer on watch was skeptical. 4,000 yards. There's no way. The hydrophones don't work at that range. Hutchins must be hearing things. But Hutchins insisted. He had the bearing. He had the frequency signature. It was a U-boat. He was sure of it. The officer decided to humor him, called up one of the escort destroyers, sent them on the bearing Hutchins had provided, told them to investigate. 20 minutes later, the destroyer reported a contact. Sonar confirmed it. There was a U-boat. Exactly where Hutchins said it would be. The destroyer launched depth charges. The U-boat tried to dive deeper, tried to escape, but it was too late. The charges found their mark. The submarine was crippled. It surfaced, crew abandoning ship, and the destroyer finished it off with gunfire. The convoy was safe, and Hutchins had just detected a U-boat at maximum passive range using a coffee can. Word spread fast. The captain of the Bogue wanted to see this miracle hydrophone for himself. When he found out it was a coffee can and some wire, he didn't know whether to laugh or be angry. But the results spoke for themselves. Hutchins had detected a U-boat that nobody else could hear. He'd saved the convoy. The captain made a decision. Instead of punishing Hutchins for unauthorized modifications, he authorized him to make more. If it worked, why not use it? Other sonar operators on the Bogue got the same modification, and the results were consistent. Detection ranges doubled, sometimes tripled. They were hearing U-boats earlier, tracking them longer, and calling in attacks faster. The Bogue started racking up kills. U-boats that would have slipped past other escorts were being detected and destroyed. And it all came down to Hutchins and his coffee can. But here's where it gets interesting. The Navy brass heard about it, and instead of embracing the innovation, they tried to shut it down. Unauthorized modifications were still unauthorized. It didn't matter if they worked. Regulations were regulations. They sent an inspector to the Bogue, told Hutchins to remove the modifications, restore the hydrophones to standard configuration. Hutchins refused. His captain backed him up, told the inspector that if the Navy wanted better detection, they'd keep using what worked. The inspector filed a report, said the Bogue was in violation of protocol. But then something happened. The Bogue's success rate became impossible to ignore. They were detecting and sinking U-boats at a rate that no other escort carrier could match. Convoys protected by the Bogue had significantly lower losses. The brass couldn't argue with that, so instead of shutting it down, they did what bureaucracies do. They took credit for it. They brought Hutchins to a naval research facility, had him explain the modification, had engineers study it, test it, refine it, and then they incorporated the design into new hydrophone models, gave it an official designation, pretended like it was their idea all along. Hutchins didn't care. He wasn't doing it for glory. He was doing it because sailors were dying and he had a way to stop it. By late 1943, the improved hydrophones were being installed on ships across the Atlantic Fleet. Detection ranges improved across the board. U-boat kill rates went up. Allied shipping losses went down. The Battle of the Atlantic started turning in the Allies' favor. And a big part of that was thanks to a guy who refused to accept that a coffee can couldn't save lives. But let's talk about why this mattered so much. Because it's easy to hear better hydrophones and not realize just how big of a deal that was. In naval warfare, information is everything. If you know where the enemy is, you can kill them. If you don't, they can kill you. It's that simple. U-boats operated on stealth. They'd lurk beneath the surface, invisible, waiting for a convoy to pass. Then they'd move into position, fire torpedoes, and disappear before anyone could react. By the time the escorts realized they were under attack, ships were already sinking. The only way to counter that was detection. If you could hear the U-boat before it got into position, you could force it to dive deeper, move away, waste time. And if it wasted enough time, the convoy would pass safely. Every extra 1,000 yards of detection range meant minutes of extra warning, and minutes were the difference between life and death. Hutchins' modification gave escorts that extra range. It gave them the ability to hear U-boats that would have been invisible before, and that meant fewer successful attacks, fewer sinkings, fewer deaths. There's a calculation that naval historians have done. They estimate that improved sonar detection, including modifications like Hutchins, contributed to the destruction of dozens of additional U-boats in 1943 and 1944. And each U-boat that was sunk meant dozens of merchant ships that weren't. It's impossible to say exactly how many lives Hutchins saved, but it's not an exaggeration to say it was thousands. And he did it with a coffee can. Now the Navy eventually caught up. By 1944, they had proper sonar systems, advanced hydrophones, equipment that was actually designed to do the job, but that took time. It took research. It took bureaucracy. And in the meantime, sailors like Hutchins were out there, making do with what they had, finding ways to survive. That's the real story here. Not that the Navy developed better technology, but that one guy in the middle of a war refused to wait for someone else to solve the problem. He took matters into his own hands. He broke the rules, and he saved lives because of it. There's something deeply human about that. The idea that you don't need permission to make things better. That sometimes the best solutions come from the people actually doing the work, not the people in charge. Hutchins wasn't special. He didn't have a degree in engineering. He didn't have advanced training. He was just a sonar operator who got tired of listening to terrible equipment and decided to fix it. And the thing is, he wasn't the only one. There are countless stories from World War II of soldiers, sailors, and airmen modifying their equipment, making it work better, fixing problems that the brass didn't even know existed. Tankers would weld extra armor onto their Shermans because the factory armor wasn't enough. Pilots would adjust their gun sights because the standard alignment was off. Infantrymen would modify their rifles, their packs, their boots, anything to give them an edge. The military hated it. Modifications meant deviations from standard procedure, and deviations meant complications. But the soldiers didn't care. They cared about staying alive. And if a coffee can or a piece of scrap metal or a length of wire could help with that, they'd use it. Hutchins was just one of many, but his story is special because his modification didn't just help him. It helped every ship that used it, every convoy that was protected by it, every sailor who made it home because a U-boat was detected before it could attack. After the war, Hutchins went back to civilian life. He didn't write a book. He didn't give interviews. He just went home. Most people never heard his name. The Navy's official records barely mention him, but the sailors who served with him knew. They knew what he'd done, and they didn't forget. There's a small plaque at the Naval Sonar School in San Diego. It mentions Hutchins and his coffee can hydrophone. It's easy to miss. Most people walk right past it, but it's there. A little reminder that sometimes the biggest breakthroughs come from the most unlikely places. And that's the lesson here. Innovation doesn't always come from the top. It doesn't always come from the experts. Sometimes it comes from the guy who's tired of things not working and decides to do something about it. Hutchins could have accepted that the hydrophones were bad and just done his job. He could have followed orders and kept his mouth shut. But he didn't. He saw a problem and he fixed it, even when people told him he was wrong, even when they told him to stop. He kept going, and because he did, people lived. That's the power of refusing to accept failure. That's the power of believing that you can make a difference, even when the system tells you you can't. The Battle of the Atlantic was won by a lot of things: superior numbers, better tactics, breaking the Enigma code, long-range aircraft. All of it mattered, but it was also won by the little things, the modifications, the improvements, the small advantages that added up over time. And Hutchins' coffee can was one of those small advantages. It wasn't flashy, it wasn't high-tech, but it worked, and in war that's all that matters. So next time you hear about some innovation or breakthrough, remember that it might not come from a lab or a corporation. It might come from someone just like Hutchins. Someone who saw a problem, grabbed whatever was available, and refused to give up until they found a solution. Because that's how progress actually happens, not through grand plans and billion-dollar budgets, but through stubborn people who care enough to try. Hutchins proved that a coffee can could detect a submarine. He proved that you don't need permission to make things better. And he proved that sometimes the best ideas come from the people everyone's ignoring. The Navy eventually learned that lesson. They started listening to feedback from the field. They started encouraging modifications and testing them. They realized that the guys actually using the equipment knew more about what worked than the engineers sitting in an office. But it took people like Hutchins to teach them that. It took someone willing to risk their career to prove a point. And that's the kind of courage that doesn't get enough recognition. So here's to James Hutchins, the sonar operator who broke the rules and saved lives, the guy who looked at a coffee can and saw a solution, the sailor who refused to accept that good enough was actually good enough. He didn't do it for medals. He didn't do it for recognition. He did it because it needed to be done. And in the end, that's what makes his story matter. Because the world doesn't change because of people who follow the rules. It changes because of people who know when to break them. If you want more stories like this, hit subscribe.